Let's jump in here, and I'm going to open up my TIA portal just like we did on day one. That brand new software, exciting feeling. Yay, we're going to learn something cool. Only this time you're learning something that pretty much very few others are really going to be all that competent with. So let's take a new project, and I'll just call this 1500 project. That's pretty explicit. Hit create, and remember, if possible, I would like you to be on the safe side and set up the same PLC as I do. So let's configure a device, add new device, make sure we're on controllers. We want the 1500 CPU. We'll take the very top on the list, which in mine is the 1511-1PN, and then I'll take the very first processor in that list, okay? So just the very first on the whole stack of processors, and that's the one I'm taking. Let's go in here to Program Blocks and get that expanded, and we're going to add a new block. This is going to be a function block. I'll go ahead and call this STL demo. Language is STL, and hit OK. And there we go. Very hostile environment, no templates, nothing that we can really drag and drop as far as STL goes. We can drag and drop some stuff, but what we get is not really STL programming, so we're going to save that for later. For right now, we're going to start working through our alarms. We're setting up an e-stop alarm and notify bit. So the first thing we want to do is we want to look at the e-stop and see if that thing's been pushed. So we start with A, which means and. Then we're going to space, and I'm going to look for my e-stop. So let me hit enter a couple of times. Right click on define tag. That's going to be global memory bool. So and e-stop. What a stupid kind of way to load a Boolean to figure out whether it's true or false. Well, think about it this way. We start with an empty plate, an empty logic that's neither true or false, and we say, oh, and e-stop. So nothing and e-stop. Well, if e-stop is true, then nothing plus e-stop is true. And if e-stop is false, then nothing plus e-stop is false. So you could also think of A as analyze, but that's not what it means. It does mean and. So and e-stop. And if e-stop is set, if that's tripped, if someone has pushed that button, then what do we want to do? We want to jump conditionally, JC space, and we'll go ahead and say e-stop detected. And that's going to be the name of our label that we're jumping to. So let's copy that, space down a little bit, Control V to paste that in, and then a colon to tell the program that that's a label. And then we have to have a command right here on the same line as the label. So I'm going to space, and what's the first thing we want to do if we've detected an e-stop? Well, we want to set our, basically latch. We want to set our alarm bit and our notification bit. So S space, and that's going to be e-stop alarm. And on the next line, we also want a S space to set our e-stop, I'll just say notify. Hit enter a couple of times, go back, and let's define those tags. So those are both going to be global memory bools. And there we go, all set. Okay, so now if we've got an e-stop pushed, we're going to set both of those bits, but we've got some small problem here. If we do this, let's pretend in the future that we incorporate our alarm silence, we reset this notify bit. Doesn't matter, we're still going to be jumping in here every single time as long as the e-stop is pushed. That's the only condition we're looking at for this jump, and we're going to be jumping all the time and resetting that notify. We're going to be setting it again, and we're never going to be able to turn off the alarm. So we need to look at another condition here. So aside from the e-stop, we also want to know, is the e-stop alarm already active? Because if it's already active, then we don't need to come down here and set anything, right? So now we've got an and e-stop. Now we want a and not e-stop alarm. So an space, and we'll take that e-stop alarm. So in order to jump to e-stop detected right here, two things have to be true. The e-stop has to be present, and the e-stop alarm has to not be present, okay? And if that's true, then we will say, okay, an e-stop has been detected, and we'll jump down here. We can also do one more thing. As far as the e-stop goes, instead of just saying, is it an e-stop, we could also put a one-shot in there. So instead of saying and not the e-stop alarm, we could also click FP, front positive, so front edge of a positive transition, e-stop. Okay? So you think about that, you're thinking about when the e-stop transitions from false to true. That's the positive transition, and the front edge of that means when it first happens, the positive signal edge, if that's true, then we want to make sure that we go ahead and trip the alarm, and that's the only time that we want to set the alarm. So this is a conditional jump. It's conditional. It's contingent upon these two things being true. So what happens then if we don't jump? Then we're just going to keep right on going down the list. Well, what's the next thing we want to evaluate? The next thing we want to evaluate is, has somebody pressed an alarm reset? So now let's clear our register. So CLR. Now we've just wiped our plate clean. And now we're going to look for A and alarm reset. And we can right click, define that tag, and we know that's going to be global, Boolean, okay. So what else do we want to look for? We want to, if we're thinking about resetting the alarm, we want to make sure that the e-stop is no longer active. So and not e-stop, okay. So if someone's pressed alarm reset and e-stop is not active, then we'll go ahead and clear these two bits if they're active. So now we can jump conditionally to alarm reset detected. I'm going to double click on that, copy it, come down here, paste it, colon because it's a label. And now we want to reset our e-stop alarm and our e-stop notify. So I'm going to copy these two commands and paste them in here. And that needs to be on that same line. So there we go. And I'm just going to change these S's to R's. So instead of setting these two bits, now we're resetting these two bits back to 0. The next thing we want to look at is an alarm silence. Okay, we're catching an alarm reset. Now let's copy all this and turn it into an alarm silence. So instead of looking for alarm reset, we're looking for alarm silence now. And that's not silence et, that's silence. We don't care about the e-stop being there anymore, so we can get rid of that. And let's define this alarm silence. That's global memory bool. And instead of jumping to alarm reset, now we're going to jump to alarm silence. And I'm going to copy this whole label section right here, paste it in here, and copy the name of it. That's going to be alarm silence detected. And now we're just going to delete out this e-stop alarm reset because we no longer want to be resetting the alarm. We just want to be resetting the notify. Got it. Now, if we're coming through this logic and we don't jump to the e-stop to set it, nobody's pressed the alarm reset, so we don't jump there, nobody's pressed alarm silence, so we don't jump there, what's going to happen is we're just going to keep running and doing all of these things every scan, which would be disastrous. We don't want that. So we need one more jump in here. This is going to be our default action. If we don't take any of those conditional jumps, then we're going to JU, jump unconditionally to, how about we'll call it end of line, okay? A nice Tron reference for you. Control C to copy that, come down here, Control V. So now we've got our end of line label, now that I put a colon on it. And here I'm just going to type BE, which means block end. And the same thing under these, we don't want it to finish this and then run right into the next label. So we're going to come down here and type BE. We're going to add a BE line here. And we really don't need a BE line here because it's going to run right into this one. But just to be organized, I'm going to go ahead and put a BE on there. So now, anytime we get to a point where we want things to stop evaluating in here, I'm just going to throw a BE in there, and that should take care of it. So I think we've got ourselves a program together here. Let's go ahead and run it up and see if it works the way that I think it's going to work, because I am not the world's renowned best quality top-end expert ninja samurai on STL programming, and I have never met the person who is. I don't know anybody who takes this upon themselves voluntarily, okay? This is a nightmare. So let's go ahead and load this up onto the PLC, if it even compiles. And I don't see any errors yet, so that's probably a good thing. Load. And did I remember to call this from our main? Let's go ahead and start the module, and then let's check that out. So on our main, we haven't even called this, so let's put the call in there. Give it a data block, and let's go ahead and load this program again, because if we don't call it, it's not going to run, and our demo is going to be really, really crappy, okay? So I think we've got everything set up. Let's go ahead and set up a watch table. So coming in here, what are we setting here? We want to work with our e-stop. We want to work with our alarm reset, our alarm silence, and we want to be monitoring our e-stop alarm and our e-stop notify. Okay, that's how quickly you can set up a watch table. If you were watching, I hope you didn't sneeze, you would have missed it. And as of right now, everything is false. We don't have an e-stop, we're not pushing alarm silence or alarm reset. So let's test this thing and see if any of it works. I'm setting my e-stop as true, and guess what? My e-stop alarm and my notify did not energize. So Paul did something wrong. Let's go back in here and see what it is. When I was putting in the FP, I was referencing e-stop again, and I think this is where I need to go ahead and create a storage bit for my front positive. So let's try creating a storage bit, and we can go ahead and put this into local static define. Okay, so yeah, now we're loading our e-stop into our register, and then we're checking what's in the register to see if it's rising edge on a transition to positive, and we're storing that last scan result into this variable that I just created here. I think that will work. Let's give that a shot. No action. We want it to reinitialize, load. Okay, we're running. Let's go back to our watch table. Everything's false. Okay, true, and all right. That was it. Now we've got our alarms set. So let's check our alarm reset and see if it does anything. We are hoping that it does not. So we've set alarm reset to true, and look at that. Our alarm and notification are still there. So let's go ahead and set our e-stop to false. Well, actually, before we set our e-stop to false, let's go ahead and turn our alarm reset off, and let's test our alarm silence, because our alarm silence should work right now. So let's send that in, and yes, our e-stop notify has disappeared. And whoops, let's go ahead and turn off our alarm silence button, so we let go of that. Now we're going to disable our e-stop so that button is no longer pushed. And now let's test our alarm reset. So now we're going to try to get rid of that e-stop alarm. And sure enough, that daddy is gone. Okay, now we have a working project. We've got a working demo here. So take a look. This is what an alarm looks like once this thing is actually programmed correctly. I don't have my stupid little, wrong register mistake on the FP instruction, the front positive. So you can tell this stuff isn't scripted. This is really me programming on the fly. So just one more walkthrough of this so that it really I'm trying to make this sink in with a little bit of repetition. The first thing we're doing is we're calling an AND e-stop, which means we're loading e-stop into our register. And e-stop, of course, is either going to be true or false. So now we're looking to see if it's true, but the front positive is asking not just is it true, but did it just turn true? And if so, then we still have a true on our plate. And if we have a true on our plate, then this jump conditional says, hey, if there's a true on the plate at this point, we need to go to e-stop detected. We need to set the alarm bit, set the notification bit, and then bug out of this block. Okay, go back to main. We're done here until the next scan. And then when we come in the next scan, we just got done setting our alarm. We say, so is e-stop true? Yes, it is. Did it just turn true? No, it did not. Okay, then let's not jump. Let's clear out that register because we don't want any trues or falses on our plate. Let's start with a new value. Okay, how about the alarm reset? Is anybody pressing it? And let's pretend that the answer is no. Okay, then what about this e-stop? And at this point it doesn't even matter, because the fact that this is false, this AND is automatically going to be false. So when we get to this jump conditional, we know we've got a false if either one of these is false. And in this case, the first one was false. So we already know we're not going to make this conditional jump. We're going to come down here instead and say, what about alarm silence? Is anyone pushing that? And we're going to say, no, not yet. So, okay, well, we're not going to do this conditional jump. Well, this is an unconditional jump, so we're going to jump to the end of the line. Boom, we're gone. Okay. Next scan, now we're going to pretend that somebody did push the alarm silence. So we already know e-stop, yes, it's on. No, it didn't just go on. The alarm reset isn't pushed, so we're not doing this. The alarm silence, yes, it is pushed. Then let's go ahead and do a conditional jump. Because we have a true on our plate, let's go down here to alarm silence detected. And we're going to reset the e-stop notify. Boom, we're done. So now, okay, alarm reset is no longer being pushed, or alarm silence is no longer being pushed. Now, let's pretend somebody has gotten rid of the e-stop. So the e-stop condition is eliminated, but now they're pushing alarm reset. That button is being pushed. So is the e-stop true? Is it being pushed? No. Okay. Did it just become true? Well, it's not true, so it didn't just become true, so we're not going to do this jump. Let's clear our plate. What about the alarm reset? Is that being pushed? Yes, it is. And what about the e-stop? Is that not true? Yes, it is not true. Oh, good. We have a true on our plate. So in that case, we're going to go ahead and jump to alarm reset detected. We're going to come down here. We're going to reset our e-stop alarm, reset our e-stop notify, and boom, we're going to bug out of this function. Just a little bit of housekeeping that we could throw in here if we wanted to be extra detailed. After this JC right here, we could go ahead and put a CLR to clear out our register one more time for a fresh evaluation. And also, we could, on the alarm reset, we could also go ahead and put an FP in there so that we're just evaluating on the front edge of that. Let's right click, define that as a local static bool. And same thing right here. We could FP ONS3 that guy. Right click, define tag, local static. So now that's a little bit more professional of a program, because now when I push the alarm reset button, it's only going to jump down here one time. It's not going to jump down here for 50 scans while my fat finger is pushing that button down. Same thing for the alarm silence, okay? So, you know, it was working before. You can say, Paul, you didn't need to do that, but this is a better program, and if I get in the habit of creating logic like this, that's robust, that works precisely,